the bare metal parts of the BioGears SDK and where we plan on taking it as we increase our version number towards an eventual 8.0 release. So for me, our major number, though the one in front currently at 7, is a SDK promise to the user that lines as we increment 7.4, 7.5, there is a high level of compatibility to the previous version as long as you've been keeping up to date. When we make a breaking change that is going to require you to do a lot of editing to your code to integrate with, that's the time that we increase the major number, or when we add a number of features that are so substantial, the cumulative effect is that it no longer looks like early versions of 7. And so today, I basically just want to discuss our roadmap on approaching 8.0, some of the nice end-user features that we're going to implement as we get there, and then a warning to a few things that will be disruptive once we have time to implement them, and encourage community feedback through the issues page and all of these suggestions to discuss ways that they could be less impactful, or to make sure that the community agrees with me that they would be beneficial and make BioGears easier to work with and have less complications when you try to use it asymmetrically in a very large integrated project. So as an aside, a lot of our experience of using BioGears over the last few years has either been in integrating it in embedded systems, which need to run outside of a traditional desktop environment, or as large-scale front-end integrations where somebody is going to build something that drives BioGears and treats it like a delivery channel for data that they're going to visualize to the front end. And so that motivates a lot of the things that we want to do with BioGears on the back end, in addition to add models and everything that end users need to increase the fidelity. So the number one feature we're going to talk about today is the availability of event callbacks in BioGears. So currently, it's very cumbersome for coders and integrators to check to see if the patient has died or gained diabetes, maybe become tachycardic. And I would like to simplify the amount of boilerplate code that they need to write for these events by creating a way for them to give us the function pointer that they want to run when these events happen and for us to execute it. And this will be modeled off of Qt signal and slot implementation. Boost also has an implementation that's very similar. And so we're going to model our extensions off of that and try to make it very similar in the way it's exposed. The next feature, which is very motivated by embedded development, is the existence of a new library in BioGears that is a file I/O fallback. So when you're working on a system that no longer has disk access, you can still use BioGears. And if you know anything about the way BioGears runs in its first couple of seconds being loaded into memory, you realize that it parses about 53 XML files to get definitions. And the reason we do that is so it's configurable, so you can edit those between runs and change the way that certain things behave, and also give end users the power to modify BioGears' default behavior as they experiment with things that they'd like integrated. It's just a faster development effort. But it does come with a burden that the files need to be laid out with respect to where you are at the time you execute BioGears. And until 7.2.0, it was very hard to have alternative installation layouts for BioGears. So just everything that we can do to make it easier to run BioGears on an Android phone or an Apple phone, or even like an embedded chip that's part of a training mannequin, we want to do. The next thing, which we might get into some detail about, is that I would like to deprecate the scenario executive class, which is like one way to implement running scenarios in BioGears. It helps us with our command line utilities for doing threaded BioGears, where you run multiple simulations in parallel. But I would like to update it and move it towards the methodology that we've been using in all of our UI integrations, where we basically rewrite it And so we'll probably expose a second scenario executor and have them in parallel for a while, and then slowly deprecate it and remove it from the code base after people have had time to migrate and prove that it works in a way that they like. Scenario language 2.0, we discussed that earlier today, but it's the inclusion of branching and loop mechanics inside of our scenario format so that you can encode more complex scenarios with less syntax. The ability to schedule reoccurring events over a long period of time if you're running sepsis and you need to do repeated treatments. The ability to simulate if a treatment happened and if a treatment didn't, and then hopefully eventually add into it the ability to do branch conditioning off a data request live as the scenario is working. Now, the scenario language is just a schema definition file that we have, so we're going to extend it to be able to express all of these things, but we also have to extend the way scenario executor works so that it supports it, and there's an out-of-the-box reference implementation of how to use it. And then the final feature enhancement that we're really pushing for is to increase language hooks that reduce the barrier for entry for using BioGears. We want to create a complete C-level interface for BioGears that can easily be wrapped with a C# and a Python native environment hook, and then you'll be able to just import BioGears in Python and create a physiology engine and then run it. So when you're doing some really early testing of how BioGears behaves, you get a smoother integration pipeline, hopefully one day supported in pip, to do that testing before you do it in the bare metal and base C. Now, we might not have time today to talk about them in detail, but I do want to cover that we have some impending API changes that we should warn people about. The first one, which is pretty major, is to remove the BioGears class from BioGears and just merge it with a class that is called BioGears Engine. The BioGears Engine is a multi-inherited class from the physiology engine interface and a BioGears concrete implementation of what we think physiology should look like. It creates a triangle of casting when you want to access certain members of BioGears for integrators. It's very complicated, moving up and down the pointer pipeline if you can't do everything as viewing it as a physiology engine. And so by merging them, you'll only have two views. You'll have the BioGears engine view, which allows non-constant time modifications, and the physiology engine, which guarantees that you don't modify anything in BioGears that could cause an advanced time to fault. And so we're giving developers the power to do things that may not have been intended, but warning them in the documentation when it's dangerous inside of the BioGears engine interface, while protecting them in the physiology interface that everything that you do here is safe and more sandboxy. There's a couple of naming changes, and I'll outline this when I create the issue on GitHub, that we would like to change to match kind of the C++11 style for creating smart pointers. It's mostly just a lot of create this being renamed to make underscore, and a few other just implementations that'll pull this in line with modern C++. And then finally, probably depending on how you've integrated with BioGears in the past, the most dangerous change that we might make coming in the future is to replace our XML-based serialization with a JSON format so that we can get faster marshalling and unmarshalling steps to convert it to binary streams and send it over the wire. If the only way that you interact with our serialization interface is to serialize states out and to reload them, this will be a transparent change for you. But part of it will require that we remove all of our CDM namespace types from our API layer. And so there will be a very binary incompatible version of BioGears, which is most likely when we'll increment that major number when we do this. Because right now, all of the SE types have a load and unload version of BioGears, and it function inside of them, and it exposes the serialization implementation to the API layer, which causes a problem for Windows integrators because our chosen version of serialization exposes templating from standard string to the API layer. And so I heavily want to remove this so that we can have easier integration on Windows platforms for Unreal Engine and Unity integration. in the near future, and allow us to modify the serialization in the past. Let me read that for a second. 1 second, Doug. So if we removed that step, you'd no longer have to deal with the XSD generation inside of CMake, but it would probably get replaced with protobuf as a first test, because protobuf has a writer that automatically allows human-readable JSON format. But if I really want to do fast serialization over wire that's never going to be read by a human, I still have binary support. And I really like this idea. And all of my testing, the time it takes to serialize a state and reinflate it for deep cloning is 4 to 2 magnitude faster. And as much as I love Xerxes, I really just do not like the XSD backend that we have because of a couple of inheritance choices. And I have tried to, without getting too detailed into it, create a couple of patches of XSD that do composition over inheritance for string and vector. But because of some operator overloading and implicit casting that they do, it doesn't work as cleanly as I would like. And so I don't know if like a XSD 4.0 would solve this problem, 5.0, because it's currently on 4, versus just going ahead and ripping off that Band-Aid. The problem is if you've integrated with BioGears by using like process action handing us XML, we are most certainly going to have to provide to the community a translation tool that will parse in XML and spit out the JSON equivalent, because it's too much of a burden for people to be expected to change that. And so this isn't a change we can make pushing to master and not explain to people what's going to happen. It's something that we're going to have a long-term branch on, prove it works, allow people to test with it, and then once we're ready, create a timeline of when we would switch to it and call that 8.0. And it might create a burden of maintaining the 7.4 line for a year or two while the 8.0 line gets maintained as well, because theoretically the only major difference would be the existence of those unload and load functions and what a serialized state looks like if we do our job right. So I do have about half of this work for review in an older branch that I keep rebasing on master, but it's going to need a second long-term pass at the end of the summer before it's really ready for external third-party review. But anybody can email us if they want to know their branch name and kind of look at the concepts I'm thinking about. So then some quality of life changes that I'm considering and would like to talk to the community about over the next couple of months. It's just that review of the third-party dependencies for Xerxes C that Doug mentioned, and replacing log for CPP with an equivalent logging library that is maintained. Maybe incorporating the log for CPP code into BioGears and self-patching it ourselves so that you no longer have to compile it, and CMake does it for you. I would like to refactor internally our dimensional analysis classes. We call them SE scalars. I want to migrate our code towards using the built-in arithmetic operators to better express our model code cleanly, and to migrate all of our unit conversion to compile time, if possible. So we have a header in BioGears Common, which is like this collective group of code in BioGears that only requires the C++ standard to build, that can do all of the equivalent dimensional analysis that we do in BioGears in compile time. But you know, migrating away from the universal engine that we currently use, which is the runtime engine, is a big overhaul. And we have to make a test harness to guarantee that we get all the same numbers we do with the new way of storing our doubles and converting them as we did with the old version, because any subtle change in that arithmetic would create large deviations between releases. And then I think Doug probably has some interest in this part. An audit of the way that we handle errors and exceptions in BioGears is very confusing unless you've been on the team for a long time. I want to make that uniform and documented across the whole code base. And I want to clean up the way that we express our memory model in BioGears for when we're giving you ownership of a pointer we return to you versus when we're claiming ownership of a pointer you pass to us. At the very least, this means to document it for every function in BioGears, and at the extreme end, it means to change a couple of API calls so that they clearly express what's constant, what's not, and what's a reference and what's a pointer. But all of this would be well documented and discussed amongst the community before any of it hit live for release. So this is kind of like a visualization of how I track this internally when making pitches of how hard something is to implement and the amount of work required versus the benefit to the community, I think, so that we can prioritize these changes. And so this is the first 6 changes that I mentioned. Now you can see that the callback availability is a lot of work on our end to make sure that we uniformly use it everywhere that, like one of the callbacks, for instance, in reversible state would happen. But I think it's the maximum benefit to the community. Having written 2 UIs for BioGears now in both Unreal and Qt, I can definitely tell you that your front-end code would just be massively simpler if you had this. And there would be way less conditional branching on trying to detect where you are in your own state logic for where BioGears is and reacting to it. The other major thing I think that's a benefit is that file I/O. Anytime you try to repackage BioGears on a non-standard platform, making sure that you actually have the right relative path to your substance definitions and patient files is critical, and this would allow you to have a fallback that never requires you to reach out to disk. Several of the others that you can see. This will help us make our timeline for actual implementation possible, and we publish this presentation as well after the conference so that people can give us feedback on if they think things should be moved. This is another view that we have that just kind of explains our thought process of what each one of these changes does to the usability or the user power of BioGears as they're implemented. The order of the implementation isn't very critical, but you can see that like the improved scenario executive will hopefully give more user power, not necessarily make BioGears user-friendly, but the callback will do both. And so we can kind of prioritize the movement that we want based off of feedback from our integrators on what parts of BioGears they use. So these are the other 5 quality of life movements. Again, third-party dependency review, unit refactor, uniform error in memory model. Probably that ownership model is the hardest thing that we have on here other than the substance definition class. And I think if we can clarify that to end users, there will be less bugs when integrating into BioGears where you accidentally break the memory model across DLL boundaries and either create an unexpected memory leak or create bad pointer arithmetic because we expose so many template classes to our DLL bounds. It makes it hard to calculate the actual size of an object once you've inherited from it. Okay. So for all of this, after tomorrow when this is done, I'm going to open up an issue for each one of the things I've listed. I'm going to keep them open while we work towards them, and anybody is willing to create an open discussion about them, whether they want to, and we're very open to listening to our community because you're the ones who deal with this. If nobody wants it and it's a mistake to pursue it, then we're going to sideline it. So please engage with us, post proposals that you would like in addition to the ones that we've mentioned, and let us create a dialogue and work together with you to patch BioGears and make that functionality. So as a kind of a background, BioGears is broken up into 3 API layers. We have the common data model, which is all of our XSD code generation and Xerxes. The synthetic environment model, which is our own personal C++ abstraction of the CDM, which is the API that I encourage most end users to use the most. And then the BioGears engine, which is a concrete concept of what we think human physiology looks like. The reason the synthetic environment exists is so that people can make parallel versions of the BioGears engine that focus on different physiology concerns. Maybe you wanted to create animal gears, or you wanted to create a BioGears Lite that had less fidelity but ran faster on embedded platforms. You could implement all of this without changing much of the synthetic environment interface because the concrete details of our models are in that third layer. And they would be somewhat interoperable with each other because they would all return a physiology pointer that would allow you to advance time and be comparable. So moving forward, we're definitely trying to stress these three things. The point I want to make here is that the common data model I consider somewhat dangerous to use. Right now in BioGears, you have to use it. Loading and unloading, marshalling and unmarshalling any class requires that you use the types. Several of our functions require that you use the enums that are in it. And I think this was a mistake in our API design 7 years ago, which locked us into a lot of permanent implementations of a third-party dependency. And so moving forward, all of those enums are going to get recreated in the SE layer. We're only going to try to express the CDM layer as the serialization backend. And once we can totally remove it from our API layer, we're no longer even going to export the symbols in the CDM. But the insight for that is we will expose functions for every class that allows you to serialize it just by handing it a data stream to an SE equivalent. And so you'll be able to write and load files, but you just won't really know what the implementation of how we write those disk is. And I think that's more powerful to the user, and I think it will help the user as we advance through versions of BioGears. So to go through, I think we have time to go through about 3 of these major changes, and so I picked the most user-friendly ones that I think will be the most interesting and things that we can release in the 7.0 line as we work towards 8.0. The first one, again, is the event and signals and slots. So I want to make it easy to detect when something happens, and I think the easiest way to make that is to not require you to write an if statement. So to support functional paradigms, I want to expose the ability to set functions that execute upon certain events happening in BioGears. And the main benefit for this is that C++ integrators can reduce the way they handle specific events occurring down to a single Lambda function that they're going to write, or one function implementation for a class that they're going to pass to us. And it can be a very complex function because with the functional header and std bind, you'll be able to wrap those complex functions into the format that we need it to be to execute. This will also allow us to maybe make more advanced slots that input parameters and execute things based off of how the death happened, or the exact values of the event that are going on. I think it will simplify some real-time BioGears code as well for our ARM branches. And so to talk about what this would look like for implementation, there are 2 approaches I can think of. The first would be kind of, as I'm calling it, the Chronos or the glut model, which is to have one C function, style function for every slot that we have. And it takes in a specific function pointer of a return type and input. And then when we trigger one of those events to happen, it'll execute your code. Now the problem with this is we need to document every one of these functions and write like a blurb about what they do when they go off, which I think we could better handle on our documentation website. So this second implementation is based off of Qt, which is kind of like a Kerblanc signal and slot where we either have an enum or you hand to us our slot mechanic, our signal mechanic inside of the connect function, and then you hand us your slot, which is the name for the function of code that will execute when this fires. And so I have a long-form implementation of that, of defining a death slot that just sets patient dead to true and then pauses a background thread. And then you call connect on death and you hand it that lambda. Now everywhere in the code that we send the signal irreversible state achieved, we're now going to execute this code. And if you're doing a lot of background processing, your thread will now be able to shut down automatically. You won't have to continue to query at the end of every one of your main loops is the patient still alive? Is the work over? Should I exit? Some of these things are done by our Boolean returns and functions, like advanced time being false normally means you should drop out. It's never going to be true again. But I think this is just a more clear interface, a little bit more modern, and will give you more power on everything that you can do. So the next feature is the file I/O fallback, which we will implement in a couple of phases. The goals of this are just to create a third optional library. So it will be controlled in CMake with a switch on whether it gets built or not. And when that library is built, we're going to serialize for you all of the required files in shared data in our source tree into this library embedded as const strings into a header. So it'll be a very big library, which is why it'll be optional. But then anytime we run into a parse error or we can't find the file you requested on disk, if we know the string that should have been loaded, we're going to load you the authoritative version from the compiled library that's compatible with BioGears. And so if you have disk corruption or it's just not possible for you to have a standard file system layout that allows us to find the patients or states folder, this will be an automated fallback. Lastly, while we're doing this, I think it's time for BioGears to respect the concept of PostFix environment variables to allow you to have like global installations of a version of the data runtime library for BioGears and not keep it where you keep the binary. And so the first step of the file I/O fallback will be to support a BioGears data root dir and a BioGears serial root dir that explain where all the XSD files are for the schema definitions, and then where all these substance and patients files are. So you can set those without rewriting your code, and it'll automatically adapt to where they're located. So with that comes a couple of things that we need to implement. If we're going to go ahead and store all of this, that library probably should have the ability to write it for you to see what it originally looked like. So we will have the ability to regenerate the file structures and the ability to give you a hash of what it looks like inside of our own code so you can compare it to your disk and know if they're equivalent. For all of this, we're going to have to integrate into CMake some form of creating C++ hex-encoded headers for our XML. Raw strings are great, but we can get a tighter way to encode all of this if we use something like XXD or BinFS. Utilities often available on Linux, but not necessarily available on Windows. So it's something we have to look into to make sure that this is a feature that could be supported on all platforms and that CMake can search for those utilities and make sure they're available. The benefit of embedding them this way so that your local copy of CMake automatically creates this is that if you wanted to modify, because you're working on BioGears, your shared data, you'll be able to build this to match your version of it and not what's checked into GitHub, and then distribute that with your self-contained modification. Again, all of this would be controlled by the presence of a BioGears NoFS define in CMake. So if you turn it off, BioGears is going to continue to operate with the exception of the ENV variables as it used to. And when it is there, then we will fall back in a specific order that will be documented. The first is you request a file and it's not found, we'll fall back. The second is if you requested that file and we parse it and we get an I/O exception out of XSD, we're going to fall back. And every time we fall back, we're going to log that message very clearly that what you requested was either not found or did not parse, why it did not parse, and what we loaded instead. Our rationale and takeaways: improved cross-platform support, robust data directory protections, and easier to maintain front-end integrators, and 2 new control directories for being able to have parallel instances of BioGears and redirect the same executable to what it's going to read. Finally, I think we have a little bit of time to talk about the scenario definition language. When this presentation's published. It does have slides for everything that I've mentioned, so as a start for a communication point, but I think it's a good place to wrap up today, because this is the most end-user power that I think we can give you going forward. And that's to create some type of context-free language inside of the scenario definition schema for creating state graphs. So the motivation behind here is definitely to create a large batch run of simulations that take every possible branch at the same time. And then a stretch goal is to allow us to do context-sensitive branching, where you pull a data request from BioGears in the schema, like the heart rate, and then choose whether to apply an action based off of those data returns. The first pass, we have a very clear outline of how to implement. In the second pass, I think we can get there, but I want to deliver something to the community first to make sure that it's useful. Some other goals would be the ability to perturb action variables when creating random scenarios. So instead of like writing that the value is 1 millimeter per second, you write like ran 1, and you give it a standard deviation. And so every time it runs, it's going to fall within that standard deviation, but it'll be slightly different, and just allow people to create a little bit stochastic runs to see if we should incorporate those features into the main C++ code. Some of the predicates that we're thinking about supporting as we go through this, the first 3 are branch, the number of times that you basically X, either take this or don't take this, or branch X and Y, which is the same as an if-then-else implementation. And finally, a for range loop, where you create a list of actions over a period of time in the scenario builder, and then you tell it to continually loop over those range of actions once they've been completed for a number of times. It's very useful for like long-term disease treatments in the sepsis scenario, or if you're creating conditions for PSC and you need to save states every hour into treatment to create that state graph, to create that repeatable loop. For the second phase, we would need to be able to open up arithmetic to the language, Boolean operations, and data request. And I think with that, we would have a very powerful secondary language in BioGears for describing the scenario actions that you want without ever coding. And this would allow front-end developers to also save their timelines and make more complex user interactions, and serialize that out in a common format that other front-end developers could use. And again, support for implementing all of this will always be in our version of scenario exec, so that there's both a common reference implementation that you can borrow from, but also a good enough implementation that has reasonable performance for you to test it out with. So that is basically everything that I wanted to talk about today. I open up any questions to the floor, and I'm here to respond.
Well, thank you. That was a great talk. That ends our day. So if anybody has any questions, just in general, on this talk specifically, feel free to chime in. So Doug says list of improvements he's excited for. So Doug works at VCOM 3D, just reference for people who aren't aware. So yeah, that's the hope, Doug, is that this makes integrators like your life a lot easier. And there are more details on each of these that will be on his slides for reference that we'll post up on GitHub once we have those PDFs later this week. If you want more details. All right, well, thank you. Great first day. So tomorrow we have Dr. Brett Talbot starting us off. We're really excited for that, starting at 9 to 9:45. So we will be online. We'll have the WebEx set up probably around 8:30. So feel free to drop in by then. That we'll then have 3 brief talks and a wrap-up. So tomorrow is going to be multi-trauma physiology, which should be a great talk by Nathan. And then a real in-depth discussion of our API examples, the new how-tos we've developed, how you use them, how you use BioGears libraries to create kind of unique projects. And then just other utility tools that the community can leverage, that we maintain, and that we build. So should be a good day tomorrow too. So hopefully everybody still joins in tomorrow. Thanks so much. We really appreciate everybody. We really appreciate everybody being able to join us. So we were actually kind of blown away with how many people were able to dial in. So thank you. Thank you so much. Are there companies in the vitamin and supplement industry? William, I'm not totally sure about vitamins and supplements, actually. I know that like the drug corporate company community does develop fairly extensively just drug models. So we've interacted with a few of them before, but we're a lot of times that code is proprietary and hard to get access to. So
yeah, I mean the other thing too for that is we have gotten a lot of questions from people in the military who study human performance, and that's something that they're interested in, looking at whether or not supplements and vitamins help. But that's kind of more of a long-term issue versus like a acute issue. So it hasn't been something that we focused on previously. But it is something we've gotten interest in.
The reason can you hear me?
Yeah, we can hear.
Yeah, the reason I bring that up is thinking from a data perspective. Again, the opening remarks were about data as a currency. And if you're looking for high transaction, somewhat controlled, but quite frankly, independent, researchers, that being the service member themselves, sounds like if there were vendors trying to package up your technology into an app onto a phone that a member could keep with them, and they were to follow a regimen, whether or not it's something akin to the whole billion-dollar diet industry in general, and we are essentially trying to make each member their own scientist. And incentivize that appropriately within the DoD and else and outside, then you can have an exponential effect on the sort of things that the FDA doesn't regulate and force people to label as not being drugs, but can really help out with the part of recovering from acute injury when you start off with higher levels of health. We have our standards in spec ops for various reasons to conduct a mission, but secondarily, it also gives you a little bit better chance of survival for the same bullet slash or exposure per se, because those initial conditions from a health perspective might be a little bit better. And it will be great to be able to get a lot of data from those who go into the training or get part of those teams and unfortunately suffer those sort of injuries, and see whether or not those initial condition variations actually do pan out to mean better incomes. And from a DoD perspective, the almighty dollar matters. And the cost of having people at higher level of medical readiness and defining what those standards and conditions are, which gets to investing in supplements or better this, that, and the other. Does it translate downstream for the percentage of people who are injured and the amount of money you have to spend to get them back to some new set point, before they're medically retired or discharged? It's a very longitudinal sort of view. But in order to get to plant those kind of seeds, to get that kind of data, and be like the Google, where they're keeping track of everything I search for, and that be okay. You have to think that way for your own interests.
Yeah. Yeah, I mean, medical planning is a huge application here. I think that's a great idea, especially operational planning, nutritional health. I mean, we have meals and we have exercise in BioGears, but it would be a matter of extending a lot of that stuff to vitamins, to other supplements that you could imagine, and then also getting the framing some of our actions and insults in the context of nutrition a little more heavy-handedly, especially with the vitamins, which we don't currently support. But yeah, I think that's a great idea.
I'm just trying to help you guys out, as you do your own business planning, let alone just building partnerships and stuff like that. And if you're really trying to ask yourself, and you look at every service member, I forget, we got 2 million or something like that. And as the wearable industry does what it does, I think hitting over $20 billion a year globally, even though that's a vanity metric to talk about here, when you're not in an acute MTF kind of facility, I mean, personally, I'm trying to get to the point of saying nominally, I should be streaming about 1 megabit per second, no matter what state of consciousness I'm in. But when I'm in, these extreme environments or in under duress or stress, then that might peak up, or it's just whatever I'm streaming at 1 megabit per second off of me as a human being. It changes in order to make sure that I get through that, or that care provider is ready for me when I get in their sphere of control. So that's a pure data perspective. There are a lot of other things you can talk about, but the reason I brought up the Joint Surgeon General, because they have a concept for health services, let alone the services surgeon generals or COMEDs, which are the heads of military departments worldwide that meet, I think, every year in June. They were in New Zealand last year. I'm really interested in finding out, from your strategic planning perspective, where you guys stand with your cohorts at that level, let alone with what you're doing here in America.
Yeah, I mean, we honestly haven't planned probably that broadly out with BioGears, but it's definitely something that we have interest in and that we have interest in supporting.
Well, I would suggest, because people can show up there like any other vendor at any other conference, that when it comes to COMEDs, COMEDES, they've got a couple of pages on the web. It's like a NATO thing that, working with the Army Surgeon General, getting the bug in the ear of the Joint Surgeon General and the Joint Staff, that so that you guys are growing up enough to get on the floor or be spoken about explicitly, especially if you think that having access, and this is what it comes down to, right? Our guys get hurt. You might or might not get into their EHR type data, but there are a lot of other people at war or somewhere generating patients in the spectrum of conflict that have your interest. And what you want to do is look at these sort of sharing agreements that could help you out and vice versa. And I think that's a form that you should probably take advantage of, or say that I tried and it just wasn't the right time.
Yeah, that's a great idea. Maybe we can be in touch more offline a bit about some of this stuff.
Okay, great. Talk to you guys tomorrow.
All right, great. Thanks, William. All right, any other questions? Okay, that wraps up day one. Thanks, everybody.